Welcome back. We next have to decide upon the drilling depth and the drilling speed. Drilling depth is adjusted by setting the depth control up or down on the scale. Bring the point of the drill down onto the work. Set the stop to the depth required and lock it firmly. If the hole is to be drilled right through the material, set the stop to approximately 5 millimeters more than the thickness of the material being drilled. Next, the drill rotation speed is selected. This is mostly determined by the drill diameter and the type of material to be drilled. Generally speaking, drill rotational speeds are fast for small diameter drills and slow for large diameter drills. Speed should be assessed using a chart which is obtainable from your local tool supplier. To change or select various spindle speeds, the spindle drive belts are fitted to different pulley sizes. Most machines show the various belt configurations and the corresponding spindle speed yields on a chart inside the pulley housing cover. In principle, however, the belt positions are changed in the following way. First, and very importantly, isolate the power supply or unplug the lead. Slacken the belt tensioning locks and pull the lever in such a way that the belts become slack. Move the belt around the pulley and onto the groove to be selected. Do this at both pulleys. The belt must be level between the pulleys. Once the relevant pulleys have been selected, then re-tension the belts by pulling back the lever and locking it. Check that the tension is correct by flexing the belt at the center between pulleys. A 10 to 12 millimeter deflection indicates a correctly tensioned belt. Replace the cover once all adjustments have been made and reconnect the power supply. The machine is now ready to drill. Start the drilling process by making a shallow cut. Then switch off. Observe whether the cut is central. This is judged by assessing the cut against the marked out witness circle. An off-center cut will appear like this. To bring the drill back on center, a small groove is cut with a punch or chisel on the wide portion. This will tend to pull the point toward the center. Once on center, proceed to drill using a firm and steady pull on the operating lever. Curlings or swarf will tail out on mild steel when the drill is sharp. Lubrication with cutting fluid is necessary to avoid overheating the point when drilling into steel. Allow swarf to break off before it gets too long. Do this by releasing pressure on the operating lever. Ease the drill through the material with reduced feed pressure as the tip breaks through. Note that it is not necessary to use a lubricant or fluid if you are drilling normal cast iron. Raise the drill when the hole is completed and switch off. Once the spindle has stopped turning, clean away all shavings with a brush. Morse taper drills are removed using a steel wedge known as a taper drift. The drift is knocked into the slot in the spindle and the bit is forced out. Allow the drill to drop onto a piece of wood. Always remove taper drifts or chuck keys immediately you have finished with them. Never leave them in the machine. To complete your work properly, you should clean the machine and put all tools away. That concludes part 1 of this series. After you've completed the practical aspects suggested, you may proceed on to part 2.